exponential modeling. So we are going to discuss how do we model uh, the phenomena with exponential function. Basically, most of the phenomena happening around us is behave exponentially. For example, the population of a country and the time and the population. So it has exponential model, or sometime with the time, the viruses, number of viruses count, let's say, it is increasing exponentially, or the value of car decreasing uh, exponentially value v, or temperature and height and pressure. When height is increasing, pressure is lowering, so it is behave exponentially. Likewise, day-to-day incidents we can explain using exponential functions. So that is simply exponential modeling. When we do exponential modeling, we should have idea about what is happening when x goes to infinity and positive and negative infinity, because most of the last question of most question is about the prediction. We have to comment on the model. We'll discuss with the example. So first of all, y equal e to the power x. Uh, the exponentials. So y equal 3x, y equal 5x, y equal 2.71828 x. So those are the exponential graph. And so I mean there are with y equal 101x or anything within this form. Y equal ax form is a constant, positive constant. But most of the places we are using this value, which is ex. I'll stay with this graph y equal 3x initially. Now, what will happen? X value. What will happen? X value is going to increasing to y value. Let's say from 0 to positive infinity. What will happen to the y value? X equal 1, y equal 3 to the power 1. So coordinate is 1, 3. And x equal 2, y equal 3 square, coordinate is 1, 9. X equal 3, y equal 3 square, so 2 square, this is 4, and 3 square, 1, 9, dot, dot, x equal 10, y equal 10 square, 100. Very fast. The y value is increasing very. See the speed of increasing. This is x equal 2, x equal 3. When this is 1, 2, 3, and 1 by 1 increasing in here. So this jump is 1. This jump is 5. Likewise, the y jumping very fast relative to x. And when x is going to, when x moving to go to the infinity, y is fastly jumping to the infinity. So what is our conclusion? X goes to infinity, then y also uh, very fastly go to infinity. Or simply we can tell x goes to positive infinity, y also go to positive infinity in this type of exponential graph. Now let's discuss. This is from 0 to positive side. What will happen go to the negative side? We'll start from when x equal minus 1, x equal minus 10, and x equal minus 100. Okay, I'll go 3 by 3, x equal minus 1, x equal minus 3, x equal minus 5, and x equal minus 100. Okay, we'll work out one sum when x equal minus 1, y equal 3 minus 1, which is 1 over 3. It's going to be 3.33. So the coordinate is minus 1.33. Then y equal 3 minus 3. It means 1 over 3 over 3. So this is going to be x equal minus 1, x equal minus 3. So this is going to be 1 over 27. So when minus 3, 1 over 27, 0.03. And y equal, when x equal minus 5, 3 to the power minus 5. Then 1 over 3 to the power 5. So it is going to be, I believe, 81 times 3. Now it is, when it is 5, 243, 1 over 200.00. And then I take another value minus 100. 3 to the power minus 100 means 1 over 3 to the power 100. So then that answer is 0.46, 47 zeros and 1.9. I mean 19. There are 0.47. Now what you can observe here, when x is going to negative infinity, do you think y value is increasing? No, y value is decreasing. So y value is decreasing to where? Towards what number? 0.33, 0.03. When it's come to 0.1, 0.33, then 0.03. So it is reducing like this. So when it is getting infinity towards infinity, to which number this y value reaching to a which number? So this y value reaching to a 0. So then x goes to negative infinity, y goes to, x goes to negative infinity, y goes to 0. So this is the only thing in the exponential you need to know when what is happening when x goes to positive and negative in a exponential graph. So this is 3 to the power, this is x. Now what will happen if it is negative? 3 to the power y equal 3 to the power minus x. Then the graph is going to be like this. So when you put negative values, as you when if you put x equal minus 2, then y equal 3 minus 2, 3, 2. So that is, so in negative area this is become positive. Because of that it is behave like this in this part. And when you put positive values, it match with this one. Because when you put x equal, let's say 5 here, so 3 to the power minus 5. And this whole positive area is similar to this one. It means when x goes to positive infinity here in this graph, y goes to 0. In this graph, y equal positive. When x goes to infinity, y goes to positive infinity. But it is opposite here because minus 3x. And in this graph, when x goes to negative infinity, y goes to positive infinity. That's the only thing you need to know basically. What is happening to x and y when it goes to infinity. The x value goes to infinity, negative and positive. So if I write again, the conclusion is y equal 3x graph, this graph, x goes to positive, y also goes to positive, and x goes to negative, this side, y goes to 0. I gave the proof. Okay. X going to negative side, minus 1, minus 3, minus 5, minus 100. This value is getting 0, more closer to 0. Now this is y equal 3 minus x. Now what is happening? X goes to positive infinity, this type of graph. Y goes to 0 and x goes to negative infinity, y goes to positive infinity. Now what will happen? This kind of a variation is there. Y equal 3x, this is positive, and then 10. Y equal 3 minus x plus 10. Now when x goes to positive infinity, y goes to positive. It doesn't matter because this x value is getting faster to negative. Then when you add, it is still 10. It's like when you add a drop of water to the ocean, still that water drop doesn't count because such big. But when x goes to negative infinity, this part becomes 0 because we simply found out that in 3x, when x goes to negative infinity, this 3x goes to 0. Then this 3x goes to 0 and this is end up with 10. Then it has a good value. So y is goes to 0 plus 10, which is 10. And same as here, x goes to positive infinity. This is become 0. This part going to be 0. In this graph, x goes to positive infinity, y, this part is going to be 0. So y goes to 0 plus 10, which is 10. And x goes to negative infinity, or negative times negative become positive, and it will follow this one. So y goes to infinity. Now this 10 doesn't count because it's very small with this infinity. So if I make a summary on this, you have two values, 3x and 3 minus x. When x increasing, it means x getting positive values, 10, 2, 3. What will happen to this one? X going towards the infinity from 0. This is become, this 3x value is going to infinity. This is become more and more. Now, what will happen? X goes to infinity. It means you are putting minus 2, 2, 3, 4, 5, all positive x values. What will happen? This is 3 minus x. What will happen to 3 minus x? It's go to 0 because uh, 3 minus x mean 1 over 3x. This is 1 over 3x. Now, when this denominator is getting bigger, 10,000, 10,000. So this is point 1, this is point 001, this is point 001. Likewise, when it is kind of 10 billion, lots of zeros, lot of zeros and 1. Now what you can see that this value is getting closer to what? 0. So that's why 3 minus x is going to 0 when x is increasing. So if we have this knowledge, is enough. Basically, we can understand what will happen to 3x when x go to infinity, it's go to infinity. What will happen to 3 minus x when it goes to infinity, it goes to 0. That's all. Now, if you can't understand what I said, that do that experiment. Applying values, then only you can understand. Experiment mean put some values and see what is happening to the exponential function. I'm going to discuss page 317, example 5. There's a formula P equal 160 times 2.71828 to the power minus 0.0060. So this is E. I just write as a number. Now when you see this one, can you think about this graph? So what is the exponential part? This is the exponential part. And what is this value? Negative. Then we are expecting B value is negative, this kind of graph. And with the time t, in that case, there should be a negative. Time can't be negative. And when t equals 0 without 160, this value is E. When t equals 0 without 160, this value is 0, 1. Sorry, the graph is wrong. I'm going this side. This value is 0, 1 when t equals 0. So any 0 power is 1. And 1 times 160, it means this is going to 160. So we didn't read the sum, but when we look at, we get an idea. And then what will happen? This exponential part, when t is increasing, this is going to be, if I rewrite 2.71828 to the power positive now, I make it positive. When t is increasing, the denominator is increasing. It means this whole value goes to 0. Yeah, I can see that. When x goes to infinity, y goes to where? 0. Now, we should have kind of idea about what is going on this sum, basically the idea behind it. The density of a pesticide in a given section of a field P. So this is P, this is 160. Can be modeled by the equation this one, where T is the time in the day since pesticide was first applied. So pesticide applied for a field, and this P is the density, uh, milligram per square meter. So what is going on here now? Apply this pesticide. Why it is reducing? Kind of a practical knowledge. To, so what is happening when you apply pesticide? So this pesticide is uh, absorbed by the weeds, and sometimes it may mix with the air, and there's a reason to density of the pesticide decreasing. So basically, so that's the idea behind it. Now, what is the first question? Use the model to estimate the density of the pesticide after 15 days. Now this is kind of a EN 10.9 knowledge. So first of all, we need to know that T, what is the date of this T? When the T, where T is the time in the day since the pesticide was first applied. Okay, so that is important about the definition of this T. So first applied and then after 15 days. So T is T measured in days. Yes, T is measured in days. So then very simple. When T equal 15, P equal 160 times 2.7. Okay, I will write E easy times 0.006 times 15. So you will get the density 146.2. Then question part B. Interpret the meaning of the value 160 here. So, so we want to get an idea when usually the starting value t equals 0, p equal 160 times e to the power minus 0.060. It means 160 times E0, 160 times E0 mean 1, it means 160. So this is the initial density when T equals 0. So we use this as an initial value, the starting value. So initial density is 160 mg m square. Initial value starting at starting. Now part D, I can see that dp over dt. It means I want to differentiate this one. So what is P equal 160 times E 0.0060. Then dp over dt is 160. You know y equal uh, E3x. Okay, 4E3x. How do you do? Dy over dx is 4 3E3x. So the same thing. So 160, then this is minus 0.006 times E minus 0.0060. So dp over dt means multiplication of this value. So you will get 0.96 minus um, e to the power minus 0.0060. So dp over dt equal, they are referring k times p. It's a bit of contradict. I need to look at this one, because if they write p value is including 160, so there is no 160 to write p. So in that case, for me, it's going to be look like this. So dp over dt equal, um, I'll bring this minus uh, 0.006 value, and then 160. I'll write here this one, I'll bring here, and e minus 0.0060. Then dp over dt equal, this is k, and this is, what is this one? This is p, 160 times this one, p. Then k value is 0.006. However, if they need the constant, so when you multiply these two together, the answer is going to be 0.96. So we'll leave it, doesn't matter, it will not affect to other sums. Question number A. Interpret the significance of the sign of your answer to part C. So basically when you multiply, you have, this one is a constant, so that is minus 0.96. So since this is a negative value, it means it shows that it is decreasing. So pesticide is decreasing if it is negative. If it is positive, it is increasing. This is something very important. Since the constant is a negative value, pesticide is decreasing. So part A, you need a year 9, 10, 11 skill. Part 2 also same. And this is since we discuss, and this is differentiation we learn now. And then this is something we knew. If we see negative value, it is mean decreasing. And there is no lot of um, big things. This is one of the easiest sum in the exam.